Thanks for joining me today. We are going to do a review of Module 4. We are going to go over everything in Module 4 that you learned that's going to be in your DBA and on your test, including some things that really weren't explained well in the lesson. So I'm going to clarify some things and give you some hints for how to work with some of these problems. So let's go ahead and get started. First of all, in 4.01, what is a function? Well, a function is a special type of relation that follows the rule for every input there's exactly one output. So all functions are relations, but not all relations are functions. Functions will only ever have one output for every unique input. So to test your skills on functions, which of these, A or B, represents a function? Go ahead and type A or B in your chat box. Justice says B. Gavin and Micaiah say B. Lola agrees. It is B. Very good. So the reason is because if you look at set A, you'll notice that 7, -5 has an input of 7, but 7 has an input of 7. Now, if this 7 right here were a -5, this could still be a function. You're allowed to have repeated points if they're the same point. But because this 7 does not equal -5, set A is just a relation, set B is a function. All right, so if y equals 3x minus 2, create a list of 4 possible ordered pairs for the function. How would you go about doing this? Would somebody like to use the microphone to explain why or how? Nope? No takers? Okay. So what we would do is we would set up a table of x and y values with the equation in the middle. And we would go ahead and fill out our x values with whatever numbers we wanted. This is our input. If our equation has this x value substituted in for where it says x, we're going to get a unique y output every time. And that's how we set up different ordered pairs that work with this function. So, and for the x values here, you can choose literally any numbers you'd like. You could do 37, 82, 95, and 140 if you wanted. I chose 0, 1, 2, and 3 just because they're easiest to work with. Yeah, that's really all, but you could pick any numbers. So what you do next, you take your input that you chose, you plug it into your equation. So I put 0 in for x, where you see it there. I multiplied 3 times 0, I got 0. 0 minus 2 is -2, so when 0 is x, y is -2. So I put that into my table. And there's my first ordered pair, 0, -2. I do it again for 1. I plug it into the equation. I multiply 3 times 1, and then I subtract 2, and I get a value of 1 for y. So for this function, when x is 1, y is 1 as well. Now I do it again for number 2. I put 2 into my equation for x. I multiply 3 times 2, which is 6. I subtract 2, and I get a value of 4 for y. So when 2 represents x, y has a value of 4. Finally, I do it one more time. 3 times 3 is 9. 9 minus 2 is 7. So here I have 3 as a value of x and 7 as a value of y. Any questions about how I did this? Okay, no questions. Let's continue. So there's my list of 4 possible ordered pairs for this function. Notice in the equation, the 3 next to the x means your rate of change is 3. So this is one of the tips that I was talking about that I was going to go over. The lesson isn't very clear about how to use the equation to find the rate of change. It focused on having you find rate of change from your list, your table, from your equation, from your line. And that's fine because that's important to know too. But there's a really easy way to find the rate of change. It's just to look at the value that is squished up next to the x, or the coefficient of x. That value is always going to be your rate of change. And if you look at your table, it makes sense. -2 to +1 is a jump of 3. 1 to 4 is a jump of 3. 4 to 7 is a jump of 3. So your change in y is 3. Your change in x is 1, so 3 over 1 is your rate of change, which is 3, which is what's in your equation. All right, which of these tables represents a function? Type it in the chat box and let me know. See a few people typing. Just say the A, B, C, or D. Which one do you guys think it is? Gavin guesses A. Justice guesses C. Mola guesses B. All right, so let's look over these tables. Now remember, in a function, your input cannot repeat unless your output also repeats. So looking at A, yeah, we have 2 inputs that are the same, but look at their outputs. They're also the same. This is basically a repeat of the same point, which doesn't really count as the one output for every input rule because it's equal. So this is technically the same point. So this one is a function. Looking at B, you have 2 repeating inputs, but their outputs are different. 4 is different from 7. So it's not B because these 2 different outputs makes it not a function. Same thing with C. X as 0 repeats twice. So we have to look at the output because the outputs are 2 different outputs for those matching inputs. C is not a function. Same for D. 0 repeats, but the outputs are different, not a function. So this one, table A represents a function. So just to recap, all of the tables have inputs that repeat, but because table A's repeating input has the same output and it's on the table twice, that means that it's still a function. Questions about this one? Okay. 4.02 talked about graphs and functions. So here's 2 different functions. Function 1 is a graph. Function 2 is an equation. How much more is the rate of change of function 2 than the rate of change of function 1? So our first job is to find the rate of change of function 1. How do we find the rate of change of a line on a graph? This is the DBA question. I'll give you some hints as you type. Anyone want to fill those in? Any takers? Rate of change from a line on a graph. Okay, I'll go ahead and fill it in. It's rise over run. Well, basically, good job, Justice. You were typing that right as I said it. So, rise over run basically means we're going to take 2 points and find how far apart they are. Rise is how far apart they are up and down. Run is how far apart they are left to right. So, rise also equals change in y, because y is up and down. So that's always our top number. And that goes over change in x, which is our left to right. So looking at 2 points, I'm going to start here at the 0. So my next point I'm going to go to is here at 2, 1. My rise goes from 0, 1, 2. So I go from 0 to 2, that's a rise of positive 2. My run goes from 0 to 1. That is going to be a run of 1. So rise of 2 over run of 1 represents a rate of change of positive 2. Another way to tell that it's positive is because this line is going up from left to right. That is a positive slope. If it was going down from left to right, that would be a negative slope. So let's go ahead and, oh, I did all this. Okay, so there we go, rate of change of 2. Now, looking at our function for the equation of number 2, there's an easy way to tell what your rate of change is in an equation. You just have to ask yourself, what number is next to x, or what is the coefficient of x? Looking at this equation, what number is that? Go ahead and type it in the chat box. Just look at the equation and see which number is right next to the x. Yeah, great job, Justice. It's 5. So, because 5 is next to the x in this equation, 5 is going to be our rate of change. And it's really that simple. You just have to check what number is the coefficient of x, and that is your rate of change every time. It could be a fraction, it could be a negative number, it could be a negative fraction, it could be a decimal. Anything paired with the variable x in your equation is your rate of change. Now, there's a few touches. It has to be in the y equals mx plus b format. And that just means y has to be on the left side of the equal sign, variable with x, and your constant has to be on the right side. If you have an equation like 3x plus 5y equals 15, that's fine. You just have to rearrange some things in order to get it to look like the y equals mx plus b format before you can start figuring out what your rate of change is. So the rate of change in the equation function 2 is 3 more than the rate of change of function 1. And I guarantee you on your Module 4 Pre-Algebra test, this question will show up. It's definitely something you need to know to do, to compare the rate of change of 2 functions. So make sure you know rise over run, so you can find the function of a line on a graph, and make sure you know that the coefficient of x is your rate of change when it's y equals mx plus b format. That's a huge thing to know for your test. So here's another example of something that definitely shows up on your test. Katie and Claire are members of different movie libraries. Katie pays a membership fee of $40 and she pays $5 for every movie she rents. The following function shows the total amount of money, y, in dollars, that Claire pays for renting X number of movies. How many more dollars does Katie pay for a membership than Claire? So what we have to do here, we have to make an equation that represents Katie's membership. So we know that Katie pays $40. This is her initial value. This is her starting point. This is her amount up front that she pays. It's a set amount. It does not change. This is her initial value. So that is always going to be B in your Y equals MX plus B formula. B equals initial value. And this is something that the lesson was not very clear about. B is your initial value, M is your slope. So that's where you're going to place the 40 in your equation. To find out how much Claire pays, you have to look at her equation. Y equals 4x plus 30. So what is the initial membership fee for Claire by looking at the equation? Go ahead and type it in the chat box. Not quite. Katie is the one who pays $5 for every movie. That would be like 5x. That's her rate of change. She pays that much for every movie. X is the number of movies. We're talking about the initial amount that they pay. It's a good guess, though. Nope, it's not 50. I'll give you a hint. Katie, if we were to put her situation into the Y equals MX plus B format, we would have Y equals 5X plus 40. And what this is, it's $5 per movie with an initial payment of $40. This is her membership fee. So using the same format, what would Claire pay initially for her membership fee? Okay, so for this one, if you look at her equation, she pays $4 per movie and $30 is her initial payment for the movie membership. So Katie pays $40 for her membership fee, Claire pays $30. You have to keep in mind that the initial value is always the number at the end without the variable. The initial value shows how much the situation started at. Because the initial value in this situation represents the membership fee, that means $30 would be her membership fee that she paid up front. The rate of change is always the value next to the variable. So in this situation, however many movies she rents, that's the input, that's your X value. And the rate of change is $4. If she rents 10 movies, she pays $40 plus 30, so she paid 70 total. If she rents 20 movies, 20 times 4 is $80 plus her initial membership fee of 30, that's going to be $110 total. So no matter how many movies she rents, she's still got this $30 membership fee that she paid. And that's never going to change. That's always just going to be her initial payment or her initial value. So in this problem, it's asking you to look for the initial value. It's asking you to see how many more dollars does Katie pay for the membership fee than Claire. That was what it asked us. So in this situation, we just had to compare their membership fees or their initial values. Katie paid $40 in the beginning of her membership and Claire paid $30. So that's a difference of $10. Questions about this type of problem? Okay. All right. So in this example, 4.04, which equation represents a linear function? Go ahead and type in the chat box 1, 2, 3, or 4. There's only one linear function in this equation. Which one do you guys think it is? Justice guesses equation 2. Lola also guesses equation 2. Any other input? Gavin or Nikaya? Gavin guesses 4. And Nikaya guesses 2. So, linear functions use the equation format y equals mx plus b. There will never be an exponent in a linear function. When you're in Algebra 1, you'll have exponential functions, so that's different than a linear function. And you don't have to worry about that until you're in Algebra 1. So, any equation that has an exponent is not a linear function. That rules out equation 1, because y has an exponent of 3. Equation 2 does not have an exponent, and it's written in the y equals mx plus b format. So that is a linear function. Equation 3 has an exponent of 2 on the x, and that does not work. Same thing with equation 4. It has an exponent of 4. Questions about what makes something a linear function? Okay. Moving on. All right, these three tables show the values for x and y. Which one represents a linear function? I'll give you a hint. When you're comparing tables, you want to have a constant rate of change. So this requires you to know how to find the rate of change and to make sure you know it's constant. So look at these tables. Which one of these increases or decreases at a constant rate? Lola is quick to vote B. Are there any other votes? Justice also votes B. Gavin votes C. Would anybody like to use the microphone to explain their answer choice? Yeah, Lola, you could type. That's fine. Go ahead and type out why you picked B. So while Lola is typing, I'm going to remind you that rate of change is change in Y over change in X. So Lola says she chose B because X increases by 2 and Y increases by 4. So looking at your table, 4 plus Y value is 8. That is a change of 4. 8 plus 12. That is a change of 4. That's good for now. So our change in Y over here is 4. Now we look at our change in X. 1 jumps to 3. That's a change of 2. 3 jumps up to 5. That is also a change of 2. So because our increase is the same number each time, this is a rate of change of 4 over 2, which is a rate of change of 2. You can simplify it. So that is going to be your constant rate of change. Now, if you look at tables A or C, you can see that they don't have constant rates of change. If you look at A, we always start with the Y column because that's our numerator in our fraction. y jumps from 5 to 8, which is 3, and then 8 to 15, which is 7. So we can't really use that one because if you look at x, it goes up steadily by 1. But because the y value does not increase at the same rate, it doesn't matter if the x value does. They both have to increase at the same rate. Looking at letter C, y goes from -1 to -6, that's a jump of 5. And then it goes from -6 to -9, and that's a jump of 3. Looking at our x values, when this jumps up to 5, over here at x, it jumps up, or it goes down, sorry. It goes down by -2, so it decreases. 4 decreases to -7, that's a jump of -3. So because they are not the same, and they're not the same ratio, that doesn't work. I mean ratio because if they go from one value to the other, I'm trying to think of the best way to explain this without being confusing. And let me go ahead and clear so I can add to this. So in our example over here in B, if we were to continue this trend, there would be 16, oops, I need my pen back. Sorry about that. There'd be a 16 here because that's an increase of 4, and then there'd be a 20 here, and that's an increase of 4. Over here, this would be an increase of 2, so this would be 7 and 9. This is if we continued our table downward. So let's say that we had an x value of 1, y value of 4, x value of 3, y value of 8, and then we jump to an x value of 9 and a y value of 20. Even though that looks like it's not a constant change, it actually is. Because looking at our table, that rate is listed in our continuation. So sometimes you have to analyze, are there missing points in between? You have to still find the rate of change by looking for a ratio that's the same. So you would say, well, this is a jump of 4, and this is a jump of 12, this is a jump of 2, and this is a jump of 6. 2 or 4 over 2 is the same ratio as 12 over 6. So sometimes it might not look like a constant rate of change, but that's how number sense will kick in, and you have to really apply your understanding of ratios to be able to determine that. So that's what I meant by the comparing the ratios when I looked at A and C. So if these numbers, like 4 and 2, give you a same rate of change, that's 4 over 2, which equals 2. And then you look at 12 and 6, 12 over 6 equals 2. That's a constant rate of change, even though the jumps don't necessarily look like it. Does that make sense? I know it's kind of confusing. Is there anything I can do to explain it better? Would anyone like me to give another example? How about this? If you're ready to move on, you can give the check mark. If you would like another example, give the X mark by doing the vote at the top. All right, another example for justice. Anyone else would like another example? Hey guys, can you vote for me so I can know if we're ready? So Gavin's good. Lola and Nikaya? Okay. So, Justice, I'll do another example at the end. I'm going to make a note right now. Table rate of change. All right, so you and I will work on that at the end. Okay. So, moving forward, which equation, sorry. So, back to this example. These are all functions. A, B, and C are all functions because their inputs are all different and their outputs are all unique. However, the only one that's a linear function, or one that creates a straight line, would be letter B, because it has a constant rate of change. All right, now 4.05 talked about different types of graphs. We have nonlinear increasing. The reason this is called nonlinear is because these dots are not in a straight line. And when you get to Algebra 1, you'll know that this is actually a growth exponential function. But you don't need to know that now. Just have that on the horizon, or just this, because you're in Algebra 1, this would represent an exponential growth increasing function. For my pre-algebra students, this would be nonlinear decreasing. For justice, this would be a exponential decay line. Linear increasing and linear decreasing. So I went over these a little bit earlier where I said going up from left to right is increasing and going down from left to right is decreasing. This is your example. So when you're trying to find the rate of change for a line and you're trying to make that equation from that line, you just have to look at it first and ask yourself, will my rate of change be positive or negative? This way, no matter what math you do, no matter which way you find your rate of change, you'll know that it's either positive or negative. Because sometimes it's confusing. Sometimes you jump down and you're like, you forget to make that number negative. And that's fine as long as overall you've looked at it and you've analyzed like, oh, okay, this is decreasing, so my rate of change is negative. That's kind of just a good thing to have in the back of your head when you're working with these lines. All right, so I have another job for you guys. You can write on the whiteboard if you want. We have some intervals to identify. You can either type in the chat box, or you can use the pen on the pen tool and write on the board. I want to know what type of interval A, B, C, and D represent. So go ahead and click the raise hand button if you'd like to write on the whiteboard. So Lola, I want you to write A. Would anybody else like to write on the whiteboard? Going once, going twice. Okay, would any of you guys like to type the answer in your chat box? Okay, so Nakaya, I want you to type B in the chat box. So Nakaya, look at letter B, type in the chat box what type of interval it is. And just a reminder, the options to choose from are constant, increasing, or decreasing. And I'm going to run out of room here. Bear with me. Sorry, it got kind of squished. So, A, B, C, and D, are they constant, increasing, or decreasing? Justice, if you'd like to do one, you can do letter C. Nakaya wrote decreasing for letter B, so I'm just going to throw it up here. Lola gave a great explanation. Would anybody like to fill in letter D? Justice wrote increasing, so I'm going to put that here. Last call for letter D. Anybody? All right, Gavin wrote decreasing. Thank you. Nice participation, everyone. And you got them all correct. Nice job. So, Lola wrote, something is stopped for a period of time. The longer the straight line, the longer the break or the rest. That's absolutely true. And the type of interval it is constant. It's not going up or down. It's left to right, which is constant. So that is identified as a constant interval. B is decreasing because if you look from left to right, notice it's going down. We always read graphs from left to right, the same way that we read words on a page, left to right. So because it's going down from left to right, that is a decreasing interval. C is increasing from left to right, as Justice pointed out, and D is decreasing again from left to right, as Gavin pointed out. So nice work. All right. So we just reviewed the major parts of 4.01 that are going to be on your DBA and your Module 4 exam. Are there any questions about the types of problems that we went over? Is there anything you'd like more clarification on, more practice? Lola is out. Thanks for joining. If you have no questions, you are free to go. Thank you, Gavin. Goodbye, Lola. Have a great day. Nakaya has no questions. Justice, is there anything I can help you with? Okay. Did you want to review that table rate of change again? Oh, okay. All right. Well, thanks for attending, and feel free to let me know if you have any questions or if there's anything I can help you with, okay?